Hello viewers, welcome to Coding Interviews channel. Hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. I have created bunch of playlists to cover various categories of problems such as BFS, DFS, dynamic programming, stacks, queues, linked lists, and so on. Please check them out. I have uploaded this code for the problem to GitHub repository. You can get the link from description below this video. Let's jump into today's problem. Number of strings with only ones. Given a binary string, a string consisting of only zeros and ones, return the number of substrings with all characters ones. Since the answer may be too large, return its modulo 10 to the power of 9 plus 7. So basically we are given with a binary string, right? So binary strings will have only the characters as zeros and ones. That's understood, right? So now we are supposed to return the number of substrings with all characters ones. So we need to find out how many strings of characters are there which has all ones first, right? So for example, if you go look at the example 1, right? So this has some few characters in it, right? This has like 7 characters in it, but how many of them are strings of only ones? We could say 1 1, right, and 1 1 1, right? So this one with all ones and these 3 ones with all ones. So these are the things, right? So these are the only 2 substrings we could say with all ones. So now we are supposed to give how many substrings with only ones that could be formed with these ones, right? So a substring is nothing but it could have one or more characters from it, right? So let's go look for this 3 ones actually. That makes it easier to understand for the 2 ones, right? So 1 is a substring, right? Obviously. And 1 1 is a substring, obviously. And 1 1 1 is a substring because a string, the full string is also a substring of the original string, right? That's why we say 3 ones is also a substring. But how many times this 1 is occurring is the question, because we are looking for number of substrings with only ones, right? So with number 1, how many times or how many substrings are possible? Since we have 3 ones in here, we would say number of substrings with 1 are 3, right? Number of substrings 1. How many? It's 3, right? Similarly, we will go and check for 1 1 and 1 1 1, right? So number of substrings of 1 1, right? So we could say the first 2 ones are the last 2 ones, right? That means 2 substrings are possible, right? Good. And how many substrings are possible with all 3 ones? Obviously there is only 3 strings, 3 ones, we will say 1, right? So that means to say the total number of substrings are 3 plus 2 plus 1, right? Which is equal to 6, right? So that means for 3, if the number of ones in a substring are 3, the total number of substrings possible are 6, right? So if you extrapolate to 1 1, right? So that means again 1 1 1 1, right? So how many ones are there? 2, right? So that means 2 plus 1, that will be equal to 3, right? So with 2 strings we will have 3, with 3 single ones we have 6. So the total will be 3 plus 6, right? Which is equal to 9. That is the answer that we are looking for, right? So basically you need to come up with all the substrings which has only ones in them, right? So that is the first step. So first step is get all substrings with ones, right? And the second step will be for each of these substrings, right, for each of the substrings, right, calculate the number of substrings again, right? Just like we did for 3 ones, it is 6 possible substrings, right? And for 2 ones, it is 3 possible substrings. So that's what I meant, right, in the step 2. And finally, right, for each substring we are calculating the number of substrings, right? We will have to sum them up, right? We will have to sum them up. 3 is sum them up. So we are given the sum may be too large, right? That's the reason why we are asked to give the modulo of 10 to the power of 9 plus 1, right? So that is what we need to do, right? So while doing like summing up, right, just summing up while doing mod with 10 to the 9 plus 7, right? 10 to the 9 plus 7, that's what the number is, right? 10 to the 9 plus 7. So these are the 3 steps essentially we are going to do. Yeah. So just to go with all ones, right? This is another example where you have all ones. The number of ones in this string are 6. That means what we are saying is how many substrings of length 1 possible? Obviously 6, right? So how many substrings of length 2 possible? How many substrings of length 3 possible? How many substrings of length 4, 5, 6, right? So if you really go look down, right, so this is 1, 2, 3, 4, 5. So this will be 5 and this will be obviously 4. It will come down to 3. It will come down to 2 and it will come down to 1, right? So this is the thing that we have to keep in mind. So now we have to go add all of them up. 6 plus 5 plus 4 plus 3 plus 2 plus 1, which is equal to 21, right? So that's the answer, right? So that's how we are going to solve this problem. So if you go look at the second step, right, we are saying for each substring calculate the number of substring, right? So the substring which I am talking about is this individual substring from the main string, and calculate the number of substrings is like this, length of 1, 2, 3, 4, whatever that is, right? So here in this particular case, length of 1, length of 2, length of 3, right? So those things, right? So how to calculate this for a given substring is the question, right? So do you have to go through all of them is the question. So there is a little technique or a pattern that you could observe, right? So if there are n, right, n ones in a string, so n ones, when I say it, n consecutive ones, okay, in a substring, let's say there are n consecutive ones. If you want to say, okay, there are 6 consecutive ones in this particular example, right? 6 consecutive ones, 6 consecutive ones, right? So if there are 6 consecutive ones, how many possible strings are there, right? Substrings. So we said 6 plus 5 plus 4 plus 3 plus 2 plus 1, right? So what do you see from here? It's like this, right? So 6 plus 5 plus 4 plus 3 plus 2 plus 1. So this gives you the sum of numbers from 1 to n, right? So 1 to 6, sum of numbers from 1 to 6, right? So there is a formula if you want to see, right? So sum of n numbers, right? Assuming n is 1 to n, right? There is a formula. What is that? N into, right? N into n plus 1 by 2, right? So why don't we apply the same thing here? So if there are 6 consecutive ones, which is nothing but 6 into 7 by 2, that is means 6 into 7 is 42 by 2, which is 21, right? Simple. So now what we are saying is the step 2, right? The step 2 for each substring, right? If we know the length of the substring, we can easily say from this formula n into n plus 1 by 2 how many substrings that could be possible, right? Let's go back to the first example and apply, right? So n into n plus 1 by 2, right? So here the substring length is 2. So that means 2 into 3 by 2, 6 by 2, which is 3, which is what is the answer, right? So again here 3 into 4 by 2, which is 12 by 2, which is 6, right? Which is what the answer is. So it holds good for all our things. So that means in the step 2, the calculating the number of substrings, now that we have a formula, right, n into n plus 1 by 2, we will be able to calculate for each of the substrings. And now it is just sum them up and doing a modulo of 10 to the 9 plus 7, right? So let's go ahead and see how we are going to do this in the code, right? So it's now it looks straightforward actually, since we have this formula and all these 3 steps, right? Let's go do it, right? So now I have this mod declared as 10 to the 9 plus 7, right? So I took this number, this 10 to the 9 plus 7, right? And we are passed with a string. Initially I am declaring this map, so we will come back to this map little later why I declared this, okay? So int substring count is initialized to 0 to start with. I have a start pointer and I have an end pointer which are initialized to -1. So now I will be going through the string length, right? So I is equal to 0 to till the length. My first goal is to find out a substring of ones, right? So that's what I'm going to do. If at all sfi is equal to 1, right, then that means I will be deeming that as my start of the string, right? So if at all start is -1, I am initializing the start pointer and end pointer at that particular index, right? Otherwise I just increment the end. What I am doing in this for loop, essentially counting the start and end pointers of the string of ones. So if you go back to this, right, so here start is equal to -1, end is equal to -1, right? That's what we said as part of this. So I'll go through 0, the first character, right? So if at all is equal to 1, no, in this particular case at least it is not equal to 1. So if it is not equal to 1, what we are going to do is we will come to that and see, okay, it's not 1 anymore, it is 0. That means if there is a string of ones that we have seen already here, how I am making sure? If start is not equal to -1 and end is not equal to -1, that means I have seen a string of ones, but in this particular case our start and end are -1s, so we don't have to do this processing, we'll just get out. So our I will be incremented to 1, right here. So now I am initializing my start to 1 and end also to 1. Going further, right, going further, my I will be 2, right? My start is initialized to 1, right? So since start is now more -1, I just increment the end. So end will be incremented 2. So my I will be at 2, right, still now. So now I is 3, right? So what is 3 is 0. So now is it 1? No, we come here. So now we check if the start and end are equal to -1 or not. No, not really. Start is 1, end is 2, right? So they are not. That's the reason why we are going to get the substring count. So what we are doing? We are passing end minus start plus 1 to get substring count function and getting the output. What this essentially is doing here is n, this is length, right? Length into length plus 1 by 2. Simple. This is our answer, right? So this is what we are doing, right? N into n plus 1 by 2, right? Yes. Once we get that answer, we are adding that to substring count. But we don't know whether substring count is really large. What we are supposed to do? when the substring count is large, we are supposed to do the modulo of 10 to the 9 plus 7. So that's what I am going to do here. Substring count mod this modulo value, right? That will be my substring count. Now I will be reinitializing the start and end to -1. That means I am done with the first substring. That means I am done until this, right? So now I am at here. So when I increment, I will be starting with this substring, right? So that is how I will be going on. And coming back to the map, right? Coming back to the map, why I am doing this map is in order to avoid the calculation of, for a given length, how many substrings are there. If a value is calculated once, I am storing them in the map. I am storing them in the map. If it is found in the map, it won't do this calculation. It just gets out of it here and return the answer, right? That just to give you the caching mechanism here, right? So if you cache the results, it will be faster. You don't have to calculate the same thing again and again, right? So just for the caching purpose, I am using the map here, right? You don't actually need to use the map, but if you use the map, it will help to do the processing faster, assuming the same length string of ones appeared more than once. So for example, in this example, right, the caching is not really helpful because 2 occurred once and 3 occurred once. But if something is like this, right, so that means the string of 2 occurred 3 times. So that means we are calculating only once, and we for the second time and third time we are just looking up from the map, right? Just to give you the little improvement, I have introduced this map function, right? So it will just, if it is available in the map, it's going to throw you the number back immediately without even calculating, right? So that is the get substring count, right? So finally we are going to return the substring count answer. So why did I have this? The start is not equal to 1, end is not equal to 1, again calculating this, because if a substring ended with a string of ones, right, we will be missing that calculation here. Just to accommodate that, I have it here. After the end of the for loop, I am doing this, okay? And just to show you, right, the idea how it came to n into n plus 1 by 2, right? We use this get substring count, right? And if you don't want to use that formula, right? Let's say if you don't want to use that formula, and how you're going to calculate it, not by using the formula, but you want to write the code, let's say. So I have another function called get substring count 2 here, right? So it is essentially doing the same thing. So it is going to get you the count like length percentile mod and putting into the count, and then starting from length 2 until the length, right? Starting from length 2 until the length, it is going to do the calculation for you and give you the count. But if you want to use the formula, this is straightforward. You don't have to really worry about it. N into n plus 1 by 2. So that's how we are able to solve this particular problem, right? So now let's go ahead and look at the time and space complexity, right? So time, we are given that the length of the string s is n, right? N is string length, right? So how many substrings are there in that n? We don't know how many substrings are there, right? But does it matter for us here is the question. We are going through the entire string only once. That means order of n, right? And for each substring, we are calculating the count of substrings with this formula, right? With this formula, n into n plus 1 by 2. So that means overall complexity, you can say order of n, because whatever the length of the n, this calculation n into n plus 1 is going to take the similar amount of time, right? It's not same, but it is similar amount of time. So that's why we are ignoring that, and we are saying the total time complexity will be order of n. And coming to the space, are we really using any space here? We are using the space for this map, but if you don't use this map, is there anything else that you are using? We are using substring count and a start and end pointer. That's it. Nothing much. So we will say order of one space. But if you consider right, the map will have the number of distinct strings, right? We don't know how many number of distinct strings are there, right, in a particular string. So we would say, or we would leave it something like there are m distinct strings, right? M distinct strings, right? In that particular case, we will say order of m is the space complexity for map, right? But if you don't use map, it is just straight order of 1. But if you use map to speed up things, it will be order of m, where m is the number of distinct substrings, number of distinct length substrings, right? Good. Okay. So now that we are able to solve this particular problem, right? If you have any further questions, please post them in the comment section below this video. I'll get back to you as soon as I can. I have posted this code to the GitHub repository. You can get the link from description below this video. If you haven't subscribed to the channel, please go ahead and subscribe and share among your friends. Please click on the bell icon so that you will be notified about all my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe and goodbye.